Hello students, welcome to our YouTube channel Experience Tutor. Today we will discuss Class 12 Physics Alternating Current, Chapter 7, ncert Solution, Part 5. Please subscribe, like and share our channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification so that you should not miss any of our videos and updates. In the previous class, we have done till question number 7.12. Today we'll start with 7.13. A coil of inductance 0.5 H and resistance 100 ohm is connected to a 240 volt 50 Hz AC supply. A. What is the maximum current in the coil? B. What is the time lag between the voltage maximum and the current maximum? So question number B, what is the time lag between the voltage maximum and the current maximum? Okay, let us see the solution. So solution of 7.13, that is inductance of the inductor of the inductor L is equal to 0.50 H. Resistance of the resistor R is equal to 100 ohm. First, we are writing all the information which are given in the problem. We are summarizing all the information. Then we'll find that whatever we need to find it. So, potential of the supply voltage V is equal to 240 volt. Frequency of the supply nu is equal to 50 Hertz. Now, part A of the question. Peak voltage. You have to remember what is peak voltage. So, in the last sum also we have done peak voltage V0 is equal to under root 2 V. So, put the value root 2 multiply by the supply voltage, that is 240. Upon solving we get 339 use calculator to solve it fast. So angular frequency of the supply of the supply omega is equal to 2 pi nu. So angular frequency of the supply is omega is equal to 2 pi nu. So two formula you have to remember. One is peak voltage and other is the angular frequency. These are two small formulas. So now just write the values here. So 2 pi multiply by 50. Put the value of nu here. So 100 pi radian per second. Now maximum current in the circuit is given as current in the circuit is given as the third formula which you have to remember in this sum, which is I is equal to I naught is equal to V naught under root R square plus omega square L square. Now put the values of V naught, R and omega. So V naught's value we have find out few minutes back. R's value is given omega square, omega's value you have just find that out, and L square value is given. Now upon solving we'll get 1.82 A. So this is the answer. Next part B, equation for voltage is given as V is equal to V naught cos omega t. Equation for the current is given as is given as I is equal to I naught cos omega t minus phi. Again this formula you have to remember. So where phi is equal to phase difference between voltage and current at time t is equal to 0. V is equal to V naught, voltage is maximum. For omega t minus phi is equal to 0, that is at time t is equal to phi by omega. I is equal to I naught. Current is maximum. Current is maximum. Hence, the time lag between maximum voltage and maximum current is phi by omega. Now, phase angle phi is given by the relation tan phi is equal to omega L upon R, which is equal to 2 pi 50 multiplied by 0.5 by 100 is equal to 1.57. Phi is equal to 57.5 pi. Phi is equal to 57.5 degree, which is equal to 57.5 pi upon 180 radian. So if we have to convert degree into radian, we have to multiply by pi upon 180. So we can write phi is equal to W omega t which is equal to 57.5 pi 180 pi upon 180. So t is equal to, we can write 57.5 pi upon 180 omega. Now put the value of omega here. So 57.5 pi upon 180, and value of omega is 2 pi up multiplied by 50. So we can cancel pi and many things will get cancelled. Upon solving, we get time is equal to 3.19 multiplied by 10 to the power minus 3 seconds, or we can write in similar form 3.2 milliseconds. This is the answer. So write it in a proper way. Hence the time lag between hence the time lag between maximum voltage and maximum current current is 3.2 millisecond. Now let us see the next sum. So next sum is 7.14. The problem statement is obtain the answer A to B in exercise 7.13 if the circuit is connected to high frequency supply 240 volt and 10 kilohertz. Hence explain the statement that at very high frequency an inductor in a circuit nearly amounts to an open circuit. How does an inductor behave in a DC circuit after the steady state? So let us see the solution. So now we'll solve 7.14. Again, the first step will be, we'll write all the information provided in the problem. So inductance. Inductance of the inductor L is equal to 0.5 hertz resistance Resistance of the resistor resistor R is equal to 100 ohm. Potential of the supply voltage voltages V is equal to 240 V. Frequency of the supply nu is equal to 10 kilohertz, which is equal to 10 to the power 4 hertz. Angular frequency omega is equal to 2 pi nu, which is equal to 2 pi multiplied by 10 to the power 4 radian per second. Now let us see the A part. So peak voltage V naught is equal to under root 2 V. Many times we have used this formula. So 240 under root 2 volt. Maximum current maximum current I naught is equal to V naught upon under root R square plus omega square L square, which is equal to 240 root 2 upon under root 100 square plus 2 pi 10 to the power 4 square multiplied by 0.50 whole square. Upon solving, we get 1.1 10 to the power minus 2 ampere. And this is the answer of A. Now answer for B. For phase difference phi, we have the relation you have the relation tan phi is equal to omega L upon R, that is equal to 2 pi multiplied by 10 to the power 4 multiplied by zero point 0.5 upon 100 is equal to 100 pi. Therefore, phi is equal to 89.82 degree. If we convert it into radian, we have to multiply 89.82 degree by pi upon 180 by pi upon 180. So it will be converted into radian. Now, once it is converted into radian, we can write instead of phi omega t. So omega t can be written as omega t equal to 89.82 pi upon 180. Therefore, t is equal to 89.82 pi upon 180 multiplied by 2 pi 10 to the power 4, which is equal to 25 microsecond. Now we have to write the description of the answer. So it can be observed that I naught is very small in this case. Hence, at high frequency, hence at high frequency, hence at high frequencies, the inductor amount amounts to an open circuit. In a DC current, in a DC circuit, not current, in a DC circuit, DC means direct current circuit, after a steady state is achieved omega is equal to 0. Hence, inductor inductor L behaves like a pure conducting object. And that's it for question number 7.14. Let us see the next question. The video is already too long, so we'll do the next question in the next class. Before we finish the class, we request you to subscribe, like, and share our YouTube channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for your support.